Hello, geometry friends. Thought that you could use a little more entertainment other than something that's on Netflix. So what I decided to do this week is make a video for you about some review of basic area and perimeter stuff. We're going to focus mostly on area because perimeter is just too easy for us to worry about right now. So let's start off with things you already know. Feel free to pause this anytime you want. I'm going to go through this stuff pretty fast because I think you know most of it. So pause it as you need if you need to write something, and then just start back up when you're ready to go. And here we go. First shape, you see it, you know it, parallelogram. How do you find the area of any shape with straight sides? We add up all the sides. Area formula for a parallelogram, and every shape that's in the parallelogram family, if you remember your parallelogram family, all parallelogram families include the rectangle, the rhombus, and the square. Every one of those shapes has the same area formula, base times height, or sometimes length times width, depending on the shape. Now notice that the height has to be perpendicular from one side to the opposite side. That's why in the rectangle, it's sometimes length and width, because in the rectangle, the length and the width, or the base and the height, are the sides, because they are already perpendicular. In the parallelogram, they are not perpendicular, so we have to drop a height or an altitude. The difference between the height and the altitude is the altitude comes from the vertex. The height can be right down the middle. For example, this segment here is a height, but not an altitude. All right, so both of these shapes, the parallelogram and a rectangle, are part of the parallelogram family. They both have the area formula of base times height, and they are both easy shapes to work with. Perimeter, add up all the sides. Perimeter, add up all the sides. Third shape, you remember, is a rhombus, part of the parallelogram family, also base times height, but the rhombus has a second option for the area formula, and that is half the product of the diagonals. Diagonal 1 and diagonal 2, multiply them and divide by 2. If you're wondering why that is that way, it's because the diagonals are perpendicular, creating 4 equal right angles. And if you take the area of each one of those 4 triangles, combine them together, that can be reduced and turned into an easier formula that is the product of half the product of the diagonals. How do you find the perimeter? Add up all the sides. Our square is a rectangle as well as a rhombus, so we can do base times height, or we can do side times side. But we can also do half the product of the diagonals, just like we did the rhombus. So another third formula here for our square, 1/2 the product of the diagonals. So we can write it as the diagonal 1 times diagonal 2 divided by 2, or we have a little more space up here, 1/2 the product of the diagonals. How do we find the area of the square? Straight sides, add them up. Our triangle. Yes, that next shape, 3 sides, 3 angles, triangle. We have base times height divided by 2, or 1/2 BH. Or if you remember from our trig unit, 1/2 AB sine C. That's the good fun formula that we learned this year. Perimeter, still add up all the sides. Then when you have a circle, some of you remember pi r squared. Some of you remember 2 pi r. Some of you will remember pi d. Pi r squared is the area. Pi d, or 2 pi r, is the circumference. There is no such thing as 2 pi r squared. That is people confusing these two formulas into one thing that does not exist. So don't do that. Our kite has perpendicular diagonals. So just like our rhombus with perpendicular diagonals, or the square with perpendicular diagonals, our area formula is half the product of the diagonals. Diagonal 1 times diagonal 2 divided by 2. Perimeter, still add the sides. Trapezoid. we take our height times the sum of the bases divided by 2. Now, I've talked about this a couple times before in class, here and there. It's a while ago. Basically, it's almost like a parallelogram where it's base times height, but it's technically the average of the bases. Because the bases are two different lengths, it's basically the average of the bases times the height. Now, if you remember, go into the depths of your geometric knowledge, the average of the two bases is called the mid-segments. So the area of a trapezoid is technically mid-segment times height. Now, our focus for Thursday or Wednesday will be the area of regular polygons. For now, I'll just give you the formula, and then we'll talk about it more on Wednesday. The area is 1/2 AP. The letter A stands for the apothem, and the letter P stands for perimeter. Perimeter, just like the trapezoid, add up all the sides, add up all the sides. This A value, the apothem, I'll show you real quick what it is, and then we'll spend more time on it later. In a circle, the radius goes from the center of the shape to the edge of the circle. If I put a circle around my pentagon or around any one of my regular polygons, the radius would go from the vertex of the shape to the center of the circle. That's the radius. The apothem goes from the center of the shape perpendicular to the side. So it's shorter than the radius. But because these are regular polygons, which means all sides are the same and all angles are equal, it doesn't matter which side we go to. Perpendicular to the side means it would also go through the midpoint of the side, and it would be the same in any direction. So that's the apothem, which is separate from the radius. And we'll talk about that more later. You'll love it. All right, those are our basic shapes. So now, we're going to do things that we've done before. We're going to find the area of the composite shapes that are shown in some of these pictures. First thing you want to do is figure out how should I break up this into pieces that are easy to work with. And you're welcome to do it many different ways, but one of the things that I usually try to look for is what's the fewest number of shapes that I can create and have an easy area formula to use. So for this first example, what I would see, or what I do see, is 2 trapezoids. 2 trapezoids means I only need to do 2 formulas. Trapezoid 1, trapezoid 2. So what I do is I draw my segment that separates the 2 shapes. I have trapezoid 1, trapezoid 2. Label them in my picture, so when I show my work, I know which work goes to which shape. I count a height of 3. 1, 2, 3, 4, 5, 6. For one base, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. The second base, I have a formula. I get a number. And I go back to the other trapezoid. Height of 4. Base of 4 there. Base of 7 there. I have my numbers. I have my formula. Total area. I add them together. Bada bing. We have the area of our composite shape. All right. Next page. A little more fun. So it's almost like a, I don't know, a fish drawn on a coordinate grid. Let's see how we can split this up. Well, here's what I would like you to do. Pause the video, split it up however you want, and find the area, and then turn it back on. I'll show you how I did it, and we can compare answers. Okay, so pause it, do it, and I'll talk to you in a couple seconds. A couple seconds for me, maybe a couple minutes for you. All right, welcome back. Here's what I did. I split it up into 3 trapezoids and 1 square. I labeled each different section with a number, so as I go through my work, I know which work goes with which shape. So shape 1 is a trapezoid, turned a little bit sideways, different from what you're used to, but is a trapezoid still. One base is 1, the other base is 1, 2, 3, 4, 5, and the height 1, 2, 3. So I take those numbers, I have my trapezoid formula, bada bing, I have my area. Section 2 is a square, section 3 is another trapezoid, section 4 is another trapezoid. Total area is just the sum of all those pieces, so hopefully with whichever method you use, and no matter how you cut the shape up, you got an area of 74 units. All right, so do this again. Pause the video, cut the shape up in the whatever way you see it, find the area of each section, get a total area answer. You may leave your answer in terms of pi, or you may leave it in terms of decimals, because the directions did not specify specifically how many decimals. We keep 4 decimal places. So pause it, do it, and then come back and we'll check it. Okay, so here's what I did. I have a half a circle, a rectangle, and this little triangle at the top, almost like the fin of a whale or shark. Shark attack. Do, 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 do. So, little triangle. First, figure out a height of 3, base of 5, base times height divided by 2. Got a big rectangle here. Area is simple, base times height. And then I have half of a circle. So, in terms of pi, my final total area is 137.5 plus 12.5 pi. I cannot add these two numbers together if it's in terms of pi, because the 12.5 has the variable pi. They're not like terms. If you carry out the decimals, carry out 4 decimal places, we get 176.7699. All right, making things a little bit easier again. This is a pentagon, but it's not a regular pentagon because not all sides are the same length. So pause it, try it yourself, and then turn me back on and we'll see how you did. All right, so this one's a little easier. I just did a triangle at the top and a trapezoid at the bottom. The triangle at the top, trapezoid at the bottom, add up to 40 total units. All right, now we get into some great stuff. We're going to figure out just the shaded region, the area of just the shaded region. So that means I want to figure out the area of this teal section in here, so like a donut ring, and then the outer section as well. So we're going to find the area of those 2 parts and add them together. So a strategy to do this is to figure out the area of each of the different circles that we see here. So I have the inner circle, like a bullseye. Then if I go to the next ring out, I'm going to get the area of the circle that goes from the center all the way out to that second circle. And then to get the area of the ring in between, we will subtract them. Then I'm going to the next ring out, get the area of that circle from the center all the way out to that. And then I will get another area from the center all the way to the outer edge. So from the radius, from the center, get the radius all the way to the outer edge. So I will have the area of 4 circles when we're done. With the area of those 4 circles, we'll figure out the area of the rings in between them. So pause me, Get the area of those 4 circles, and then if you know what to do, get the area of the outer ring and inner ring so we can add them together. In terms of pi or as a decimal, doesn't matter to me. We'll check both to see how you did. If you're not quite sure exactly what I'm talking about with the rings, then hang on a second because I'm going to explain it. Otherwise, pause it, try it, and then come back. Okay, the area of circle number 1, the inside circle. So what I'm talking about here, basically the center of the bullseye. Okay, this radius is 1, so the area of that circle ends up just pi. The next circle out from the very center of our bullseye to the outer ring, I label it circle number 2. It's going to go from the center to the outer ring. I'm essentially getting the area of this whole circle here. Pi r squared, radius is 2, area is 4 pi. So then to get the area of what we're looking for here, the ring in between, I label this as the inner ring. What we're going to do is subtract the 2 areas we just found. So 4 pi minus 1 pi is 3 pi. Now we're going to keep going with our calculations. The third circle that I need will go from the center of our bullseye all the way out to 1, 2, third ring. So that has a radius of 3 units, giving me an area of 9 pi. The fourth ring, from the center all the way out to the outer edge, has a radius of 4, pi r squared, 16 pi. So the outer ring is the difference. So I'm looking for the shaded region between the circle number 3 and circle number 4. I'm just going to subtract those 2. And our total area, 7 pi plus 3 pi, gives us a total area of the shaded region as 10 pi. Or multiplying it out, 31.4159. If you tried that on your own and you got it, that's fantastic. If you tried it on your own and you didn't get it, that's okay. Hopefully you see what mistake you made. That's called learning, finding your mistakes and figuring out what not to do next time. All right, last one for today is simple. We have a square, base times height, length times width, side times side, however you want to view it. Area of the square is 2 times 2 is 4. The only tricky part about this other piece is the fact that it's not a full circle. How much is it though? Well, if we cut out a 90-degree section, that means the amount that's left is 3/4 of the circle. And then our total area, adds them together, or in decimal form. Okay, guys, that was a little over the 12 minutes, but hopefully you did fine and you understand things, and good luck. You are done for today.